All right, welcome to the latest video, Systems of Equations. In this video, we're going to talk about some vocabulary, super important, like what's a consistent system, what's an inconsistent system, what's the solution to a system of equations. First of all, what's a system of equations? And last but not least, we're going to talk about how do we solve equations graphically and algebraically. Hope you enjoy. All right. Welcome to the latest video on what are systems of equations. Well, systems of equations are more than one equation graphed together. Most likely in grade 10 we'll graph 2, but if you're traveling down the road to 11 foundations, we graph 3 and 4. So what is the solution to a system of equations? Well, that's where the lines intersect or the points of intersection. So we're always looking for literally where X marks the spot. Let's have a look at the way that lines intersect. There's 3 different ways we can look at this. The first way is to have one point of intersection. If we know what the x value is and we know what the y value is, we know we have a point xy. Second case, parallel lines. Well, guess what? They don't intersect. They have no point of intersection. And the third case is you have essentially 2 lines on top of each other that have the same equation. They have infinitely many ways where they intersect. Every single point is a point of intersection along the axes. So, how does that relate to terms consistent and inconsistent? Well, consistent means they have a solution, namely that you can find a point of intersection. Inconsistent means there is no solution, like parallel lines. And the third set, consistent again, because does it have at least one point of intersection? Yes, it has infinitely many points of intersection, so therefore it is consistent. So there you have it, the 3 cases, one point of intersection, which is consistent, parallel lines, which is inconsistent, and 2 lines that are the same line, same equation, consistent because they have infinitely many points of intersection. Hope that helps clear up the vocab. All right, let's look at graphing a system of equations. Here's our 2 equations, y equals minus 4x plus 5 and y equals 3x minus 9. Notice that the red line is the first one and the blue line is the second one. So let's look how it graphs. Well, we start at the y-intercept, which is at 5, and then we go down a slope of 4 and 1 over. For the second equation, we start at minus 9, and this has a positive slope, so we go up 3 and 1 over. If you continue these 2 patterns, graphing them until they meet, and if you've used a ruler and grid paper and not cheated like I did with Desmos, you should find your lines meet at a value of x equals 2, and that was a bit enthusiastic, y equals 3. So your point of intersection is 2 minus 3. Let's do this algebraically so we can practice this method too. All right, let's solve these 2 equations algebraically and see if we get the same solution we got using the graphing method. So first of all, in the method that I use, I'm always looking for things that are equal. And in this case, I already have y's that are equal because they're arranged in the form y equals mx plus b, or slope-intercept form. So therefore, I can say, well, if this is my a, and that's my b, and that's my a, and that's my c, if a equals b and a equals c, you got it, b has to equal c. So now I can say minus 4x plus 5 equals 3x minus 9. And from there, I can bring that over, so that becomes positive, and this negative becomes positive, and I get 14 equals 7x, or x equals 2. Well, that sounds about right from the last one. So now what we need to do is we need to go back and solve for y. So let's just use y equals 3x minus 9. Oopsie, y equals 3x minus 9. But guess what? We found out that our x is equal to 2. So what is 3 times 2 minus 9? Well, 6 minus 9 is minus 3. And 2 minus 3, if you remember correctly from the last clip, was the point of intersection. That's about as easy as it's going to get to find a point of intersection algebraically, but good job if you got it. All right, let's find the points of intersection of these two equations. But before we do that, I just want to talk about a couple of strategies you can take prior to graphing these. So one suggestion I have, which is a nice way to graph things, is what I just call the intercept method. So if I look at the first equation here, it's not in any form. It's not in general form. It could be if you brought the 6 over and it was 3x minus 2y minus 6. It's not in slope-intercept form, although it could be if we brought the 2y over and the 6 back and divide it by 2. So it's what I call in no form. So the easiest way to work with no form is to say, well, if I make x 0, what is my y going to be equal to? Well, divide 6 by minus 2, minus 3. Okay, what if I make y 0 instead? What's my x going to be equal to? Well, what's 6 divided by 3? 2. So all of a sudden, I have 2 points I can graph. I can show you I have 0 minus 3 and 2 and 0. All right, let's look at the other equation. Now, you know in class I always say when it's in the form x plus y equals 2, the easiest thing to do is just find 2 points that add up to 2. Well, I think 1 and 1 works just fine, and I think 0 and 2 would work just fine. So that was my 1 and 1, and my 0, 2. I now have my lines going here. But instead of just guessing where they meet, let's have a look at the actual graph. All right, I've gone to Desmos and graphed these so I can get a better picture for you. So here's the graph. Based on the points that I found, I'm able to see the point of intersection is right here, 2, 0. So when you're writing a solution to this, you should always write 2, 0 as your final answer, with this being your x and that being your y. All right, let's look at these two equations algebraically. Let's have a look and see. First of all, do we have any equality? Well, I have a 3 and a 1 and a minus 2 and a 1. And we don't make the right sides equal because that doesn't eliminate any of the variables, so that doesn't help. All right, let's multiply the second row by 3. And I'm going to do that so I can eliminate my x's first. So I get 3x plus 3y equals 6. So there's my new second equation. So now what I'd like to do is get the equal terms isolated. So 3x in the first equation equals 2y plus 6, and 3x in the second equation equals, bring this over, it becomes negative, and the 6 is still there, and it's already positive. All right, so the next step is then to say if a equals b, we've talked about this before, and a equals c, therefore b equals c. So now I can say 2y plus 6 equals minus 3y plus 6, and then I can do some crisscrossing here. Well, this would become positive. Positive 6 on this end becomes negative. That goes and that goes. So I'm left with 5y equals 0. And if you have 0 money and you share it between your 5 friends, unfortunately, everybody still gets 0. All right. So we've now found our y value, but what does every y need? You got it, it needs an x. So we need to go back and check on our original equations. So let's use x plus y equals 2. So if I know that x plus y equals 2, and I already know that my y is 0, so x plus 0 equals 2, therefore x equals 2. And we already know x equals y, so you can write it like that, or you can write a little friendly coordinate 2, 0. So there you have it. There's a way to solve an algebraic pair when you had to make one coefficient equal to the other.